Hi, friends. I'm here to talk to you about intersecting lines, okay? Because we struggled a little bit today, and we got this. We can go over this. So our vocabulary, though, we start off with complementary angles. So a complementary angle is when two or more angles have a sum of 90 degrees, all right? Then we have supplementary. It's two angles whose measures have a sum of 180 degrees. Because they are on, and I'm just going to draw it now, a straight line, okay? That's 180 degrees. That's what you're looking for with supplementary. Complementary, it's a 90-degree angle. And you know it's 90 degrees because they'll give you that box telling you it's 90 degrees. Then we learned something today called congruent. So congruent is when they have the exact same measurement, all right? And that applies to vertical angles. Those are the opposite angles formed by two intersecting lines, and vertical angles are congruent. And I'm going to prove that to you. But that's when it looks like this. Well, that was not a great line. Let's try that one again. Okay, and then that means whatever angle this one is, and I'm just going to make it up. We'll say it's, 30 degrees. The one straight across from it is also 30. Not adjacent, which is the next vocab word. Not angles that are next to each other because they share a vertex and one side, but those that are across from each other. They're opposite of each other, okay? And I'll try to explain that even more as we get to it. So remember, we have our steps. First thing is identify the relationship. If you can figure out the relationship, then you can solve it. And sometimes you can even do a workaround to get to it. Once you identify if they're complementary, supplementary, or vertical, adjacent is helpful to know, but it doesn't always tell us the answer. Then you can write an equation. Complementary, they're set equal to 90. Supplementary, they're set equal to 180. Vertical, they're set equal to the given. Like if I tell you this one is 30, this one has to equal 30, but maybe it's got a variable. Okay, then solve for your variable, use the variable if necessary. So I'm starting off basic. I've got a straight line, right? I can see that. I can trace it along the bottom. It's straight. So this is a supplementary relationship. Okay, so that means that that 20 degrees plus the something, I'm just going to use x, equals 180. Maybe you can just look at this and solve it. Maybe you need to use your inverse. So I subtract 80 from both sides and I get that x equals 160. Okay, now I can erase that question mark. I know it. This is 160 degrees. Okay, it doesn't matter anything else. If I'm looking for those straight lines, they're supplementary and they add up to 180. So I'm about to show you something that tricked you guys a little bit. Look how this is almost the exact same, except, and you can even see like that my line wasn't perfect, it continues. And they want me to solve for all of them. So to not stress myself out, I'm just going to choose one of the adjacent angles, the ones next to it. I'm going to look at this one. I didn't label these, so they don't have a name. My apologies. So that angle. They're on a straight line, so they add up to 180. Okay? So 35 plus the something, I'm just going to use the question mark for right now, equals 180. All right? Well, I've got to subtract that, so that angle. And you know what? I don't like actually using a question mark. I'm going to call it X for this first one. I'll do XYZ. So X, I've got to subtract 35. I get that X equals 180 minus 30 would be 150 minus 5 more, 145. Okay. So that missing angle is actually 145 degrees. Now that I know that, guess what, friends? And I'm going to use a new color to try not to confuse you. Oh no, I erased there it goes. Not going to erase that line. I didn't realize I could do that. I'm going to use a new color. I'm looking for this angle. And I know that that 145 angle and this are on a straight line. So guess what? They add up to 180. So give myself a little room. So now it's 145 plus, and remember I said I was going to use y. Y equals 180. Well, last time 145 plus 35 was 180. That's not going to change. Y equals 35. So this right here is 35 degrees. I wonder what this missing part is going to be. So that last one, I'm going to use one more different color. Let's use green, and I'm going to have to write it above, or else I'm just going to run out of room. So now I'm looking for this. I could use the 35 here or the 35 there. They're both going to give me the same answer. Sorry, I wasn't using my cursor. I can use the 35 here, or I can use the 35 here. They're both following a straight line. It's just the way I kind of look at it. So I'm doing 35 plus x, y, z. 35 plus z equals 180. Looks just like this one. So I guess z equals 145. And it does. So when you look at these, and I'll try to erase the lines without destroying everything. Yes. When you look at these, got scared. I'm erasing it, sorry. Oh, I'm so stressed out. I did delete the 3 though, so I'll put it back. There we go. Opposite angles are the exact same. And I'm going to use yellow to show that, okay? Opposite angles are equivalent. They are congruent. Those two, they're across from each other. These two, they're across from each other. They are not adjacent. Adjacent angles could be congruent, but it is not something that they will be congruent every time. So when you have intersecting lines like that, you can solve for every single angle just by setting it equal to 180 and moving around. Sometimes though, they're gonna get a little trickier and other things are gonna pop in, and we'll see an example of that a little lower. But now that we know how to do this, we're gonna see one with some variables. It's fine, we got this. So I'm looking. It's got a lot going on, but I can do this. I've got letters, I've got my variables, it's gonna be great. So I've got 5x and x, okay? They are on a straight line, so they are supplementary, okay? I know supplementary, it means it adds up to 180. So 5x plus x equals 180 degrees. So I've got to solve for this. So, ooh, these are like terms. Remember with expressions, we can box those and combine them. So this isn't just 5x plus x, it's actually 6x equals 180. Divide by 6, divide by 6, I get that x equals 30. All right, now I know what x equals, but I need to know the other angles, okay? I didn't give instructions for this, but it said solve for x and all angles. So x is 30. Ooh, this one right here already is x, so this angle is 30. However, this angle is 5x. So it is 5 30s, 5 times 30, which is 150? Yes. And guess what? I can use vertical angles to finish this. If this side right here, right there, if that's 30, the opposite, it's vertical, is the exact same right here. It's 30. Same thing on the other end. If this angle right here is 150, then guess what? Straight across that vertex. Or sorry, is 150? Yeah, I think that's what I said. Then this one is also 150. And I could have just figured out x was 30, not done 5 times 30. It could have done 180 minus 30 to give me the 150, and then done the same thing. Could have even done it this way and gone around. All right. If I just have two intersecting lines like that and I figure out one angle, I know all the other angles. But sometimes they're tricky. They're just variables like that, and it doesn't make a lot of sense. Writing the equation will help you so much. Okay, so write those equations. All right, I'm throwing a trick one at you. Okay, it's still everything we know. I want to make this picture a little bigger though. I have not one, not two, but three intersecting lines. But either way, they're straight lines. Okay, I'm going to trace it and then I'm going to erase it all. But straight line, that's 180 degrees. That's 180 degrees. That's 180 degrees, which also means I have vertical angles here. Okay, but I can go and I can solve every single one of these angles, right? Ooh, this one right here tells me, says this is 90. So guess what? Vertical. And also because this line isn't interfering, that's 90. I don't really know if that's important for me because I got to solve for x, but it could be. But even still, I can ignore the line and I'll draw it so you know what I'm, actually no, I'll use the arrow so you know what I'm talking about. I can ignore this line, FE, totally. I can ignore it. And I could see that if this side is 90, this other side is also 90, friends. Use a different color. Because 90 plus 90 is 180. So whatever this angle is, plus this angle, plus this 90 equals 180. So, but I still don't have enough information. I need to know this piece. And wait a second, I have another piece here. Is that a vertical angle? It is right there. This angle is 22. Okay, it's 22. I have a 90. I know that those two, these two, this 22 and this x, they add up to, I got this. They add up to 90. This is a complementary set. I just had to use vertical and complementary to help me. So 22 plus x equals 90. Subtract 22. And I get that x equals 90 minus 20 is 70 minus 2 more is 68. X is 68. Because 68 plus 22 is 90. I could solve for every single one of these pieces. I'm gonna show you that. If this is 68, vertical, this one's also 68. I know the measurement of every single angle on that. Even though it was 3, I could still do it. All right, I know that was a lot, but it's because we started from the bottom, now we started with just supplementary. Then we looked at intersecting lines. Then we added some variables. Then we had 3 intersecting lines. And yes, this one seems like an escalation, but this one conceptually, you guys can figure this out. It's just straight lines. This one, the variables get a little tricky. It's the equation piece you have to practice. So if you need practice with equations, just ask your teacher for help. All right, and as always, if you need help with anything, just ask. Bye, friends.